We now have all the functions we need to get our mouse through the maze. It's just a matter of putting them in the right order. So the first thing we're going to do is get rid of the comments for the calibrate function. We definitely want this to run every time we start our mouse through the maze. The next thing we're going to do is make sure our mouse scans for walls. This will have to be carried out before we solve the maze so that our mouse isn't bumping into any walls. After our mouse solves the maze, we definitely want it to turn toward the best neighbor. And after that happens, we want the mouse to go forward. We want it to head in the best neighbor's direction. So these four commands are essentially all that are needed to get our mouse through the maze. We just need to keep repeating them until the mouse arrives at the end. So to make that happen, I'm going to use a do loop. And the big difference between a do loop and a while loop is that the condition is evaluated at the end. So I'm going to say do while the number within the values array associated with the mouse's row and the mouse's column is not equal to 0. So what's happening here is we're going to keep repeating these commands as long as wherever the mouse is at in the values array is not equal to 0. Basically, it's not at the end. As soon as it is at the end, it will jump out of this loop and it'll be done solving the maze because it's at a 0. I'm going to hit Control T to clean up our white space. And as far as what we actually need to do, this is it. This should get our mouse through the maze if everything works perfectly. However, because this is the real world and because we're dealing with a robot, it's probably not going to work. So we're going to add some debugging features. The first one is we're going to print values to the serial monitor, which will be transmitted via Bluetooth. And then we're going to, every time that maze is printed, we're going to want to have it delay a little bit so that we can marry up what's actually happening in the real world with what we're seeing on the serial monitor. So just like we make our program delay at the very beginning until we press the button, these two lines will make our robot delay every single time it goes through this loop. So as soon as it prints the maze, it's going to stop until we press the button again. So we can actually look at our serial monitor and make sure that what we're seeing matches what our robot is actually doing. And if there's a discrepancy between the two, then we can hopefully glean some sort of understanding from that. One last thing you probably want to do as far as getting your robot through the maze is to add these 3 lines of code. Scanning the walls will help us to see if it picks up the walls in the last cell, and then we can solve it. And finally, you'll want to print the maze one last time. In order to run this code, you're going to want to make sure that the initial position is correct. So on the 4x6 table, it's row 3. The column is 0, and the mouse is heading north. Here you can see the culmination of all our efforts in action. More importantly, you can see how adding a while statement, a while loop, that causes the robot to wait for the button to be pressed allows us to step through the program as the robot navigates the maze. This gives us invaluable insight into what's going on with the robot as it tries to accomplish this task. And as you'll see here in just a minute, it helps us find a bug. Here you can see the robot thinks it's gone forward when in reality it has not. That's because something's wrong with the forward whiskers function. When you go in there and take a look at what causes the robot to stop after it's started moving forward, there are two conditions. One is time. The other is if the robot thinks it's close to a wall, it'll stop a little bit early. The issue here is our robot made a turn and it still has values from prior to the turn stored in the sensor's array. When we were avoiding obstacles and navigating a labyrinth, every time our robot turned, we initialized the sensors, but we forgot to do that when we created the turn toward best neighbor function. So it's not giving the forward whiskers function good data. To fix this bug, you can initialize the sensors towards the end of the turn toward best neighbor function. If you want to make sure you only initialize the sensors when the robot turns, then you'll actually have to modify the if statement and the else if statements so that they include that sensor initialization, and that'll keep it from occurring when the robot actually drives straight. Once you fix this bug, go ahead and upload the new program to your robot and see how it's working. If you have any other bugs, go ahead and fix those too. With this tool at your disposal, you should be able to get your mouse to the target cell.